Here are the solutions to Week 2, Lessons 9, 10, and 11 in Unit 4. The first one here, for each equation in the left column, find in the right column an exact or approximate value. So let's take a look here. For the unknown exponent, so the equation is true. So we're looking for y here, the exponent. So 10 to the y is equal to 10. That would be 10 to the first. 10 to the y is equal to 20. Well, we know if we start writing out, first of all, 10 to the 0 is 1, 10 to the 1 is 10, 10 to the second power is 100, so it's just a 1 with that many zeros. 10 to the third power is 1,000, 10 to the fourth power is 10,000, 10 to the fifth power is 100,000, and so on. So that should help us. So what power do we raise 10 to get 20? Well, 10 to the first is 10, and 10 to the second is 100. So we're between 1 and 2 for these exponents, and probably closer to 1. So with this one, I would choose 1.301 probably. 1.99 is between 1 and 2 also, but that would be a result closer to 100 than 10 there. So for the next one, 10 to the y is equal to 2,000. Since 10 to the third is equal to 1,000 and 10 to the fourth is equal to 10,000, we're between 3 and 4 there and probably closer to 3. So I would choose number 6 here for that one. The next one, 10 to the y is equal to 900, and so we're almost to 1,000, but not quite. So we're between 2 and 3 here this time, and probably closer to 3, because we're right up there. 900 is closer to 1,000 than it is to 100, so I would choose 2.954 for that one. And finally, 10 to the y is equal to 4. Well, since we have something that's between 1 and 10 this time, your exponent is going to be between 0 and 1. And the only exponent between 0 and 1 here is 0.602. So I would choose that one for letter E. Number 2, here's a logarithmic expression, log base 10 of 100. So how do we say the expression in words? We say log base 10 of 100, and explain your own words what the expression means. And so this is the exponent to use with 10, or a base of 10, to get 100. So our logarithms are always exponents. What is the value of this expression? Well, we know that 10 to the second power will give us 100, and so 2 is our exponent there. Number 3, the base 10 log table shows that the value of log base 10 of 50 is about 1.69897. And so explain or show why it makes sense that the value is between 1 and 2. Since 10 to the first is 10, and 10 to the second is 100, 50 is between these two, and so it would make sense that the exponent is between 1 and 2. And so a log base 10 of 50, remember this is an exponent. And since this is true, 10 to the first is 10 and 10 to the second is 100, we know our exponent is between 1 and 2. Number 4, here's a table of some logarithmic values. What is the approximate value of 10 or log base 10 of 400? So now here we are. Remember, this is our exponent. And this is our base. And so if we look at log base 10 of 400, we're talking about the exponent we would use with a base 10 to get 400. And so our exponent would be 2.6021 in this case. And letter B, what is the value of log base 10 of 1,000? Is this value approximate or exact? So if we look down here, we end up with 1,000 here, and so our exponent is 3. And this is exact since 10 to the third power is 1,000. Number 5, what is the value of log base 10 of 1 billion, it looks like? And so I see there are 9 zeros there, so I must be raising that 10 to the 9th power. So so the value there is 9 since 10 to the 9th is 1 billion. So 9 is your exponent there. The next lesson, lesson 10, starts with use the base 2 log table printed in the lesson to approximate the value of each exponential expression. So 2 to the 5th is, if we go to our log table in this lesson, we can see that 32 is our 2 is our base, and our result is 32. So right here, we would have to use an exponent of 5 in order to get 32. So let's go back here, and we know that that's 32. And then 2 to the 3.7 power would be, here's our exponents in this right column, so 3.7 would be about 13. So 2 to the 3.7 power would be approximately 13. And two to the 4.25 is going to be, let's see, 4.25, somewhere right in here, about 19. So 2 to the 4.25 power would be approximately 19. So in the next one, use the base 2 log table to find or approximate the value of each logarithm. So now we're looking for the exponents. So in other words, what exponent do I raise 2 to in order to get 4? So let's look at that table for the 4. And so we want a 4 here. And so let's see right here. So our exponent is 2. So the right column is your exponents. The left column is your results. So this one would be 2. Exactly. Log base 2 of 17. So now we're looking at what power of 2 will give us 17. It looks like we can raise 2 to the 4.08 or 4.09 or 4.0875 to get 17. And these are approximations, so we would use our approximation symbol and go with 4.0875. And then log base 2 of 35. So we're looking for an exponent here again. And we want a result of 35, so it's going to be right there at 5.1293. Remember, with all of these, to translate from an exponential form to a logarithmic form, we would have a base raised to our exponent. So this is the exponent. This is our base. And our result is x. Of taking base b to the y power. And so to write that as a logarithm, the log, then base b goes down here, our result goes here, is equal to y, and that's our exponent. This is our result, and that's our base. When we take this base to the y exponent, we end up with x. Or if we take b to the y, we end up with x. So there's an explanation of the two. You might want to color code these. So in the exponential form, it's b to the y. That's the exponent. And then our result is x. So that's here in the logarithmic form, and it's there in the exponential form. So be sure and take a look at lesson, lesson 10. There's a good diagram of that and an explanation. So if you're having trouble understanding that, refer to lesson 10 in illustrative math. Number 2, here's a logarithmic expression, log base 2 of 64. How do we say the expression in words? So we say it by going by just what I said, log base 2 of 64. And explain in your own words what that expression means. Remember, a log is an exponent. To use with 2, that's your base, to get 64. So when it's written like that, we can say 2 to the what power is equal to 64. And that's your logarithm. We're looking for that exponent. And so, let's see, what is the value of this? So 2 to the 6th power will give you 64. So that's just the exponent. So number 3, what is log base 10 of 100? And what about log base 100 of 10? So the first one, log base 10 of 100, is asking us what exponent 10 to the what power gives us 100. So that would be 2. So that's just 2. But then what? Now we're going to have our log base 100. And what gives us a result of 10? Well, 100 to the 1/2 power, remember this is your exponent here, that will give you 10. 100 to the 1/2 power gives you 10. 10 to the 2nd power gives you 100. Just kind of go in a circle that way. Letter B, what is log base 2 of 4? So we're looking at log base 2 of 4. And so 2 to what power will give you a result of 4? And that's 2. And what about log base 4 of 2? So 4 to what power will give you 2? And that, again, is 1/2. The square root of 4 is 2, so 4 to the 1/2 power is 2. This next one here, I think they mean to switch these around here. Express A as a power of B. So since A squared is equal to B, A would be B to the 1/2 power, or the square root of B. So I'm pretty sure that's an error there. And also on your key, answer key, there's an error. Lesson 11, number 1, select all expressions that are equal to log base 2 of 8. So remember, we're looking for the exponent that you would use base 2 with, with base 2 to get 8. And we know that 2 to the third is equal to 8. And so anything that equals 3 here is an equivalent expression. So 5 to the what power gives you 20? I don't think that's going to be 3. But 5 to the third does give you 125, so that would be a good selection. 10 to the third power is 1,000, so this one's out because this is 10 to what power gives you 100. But D would be in. That would be equal to 3. This is a exponent of 3. E would also be in, since 3 to the third is 27, but F is not 3. Number 2, which expression has a greater value, log base 10 of 1/100th or log base 2 of 1/8? Well, we know that this one is the exponent -1, and we know that this one is the exponent -2, because 10 to the -2 power is equal to 1 over 100. So this exponent is -2, whereas this one would be -3. So this is the greater of the two. -2 is greater than -3. And finally, number 3, Andre says that log base 10 of 55 is equal to 1.5 because 55 is halfway between 10 and 100. Do you agree with Andre? And no, we don't agree with Andre. It is true that 55 is halfway between 50 or 10 and 100, but let's see. So 10 to the first is 10, and 10 to the second is 100. And so we know that our exponent has to be between 1 and 2, but checking on a calculator, 10 to the 1.5, that's equal to, let's see here. That's equal to 31.6, which is not 55. So 10 to the 1.5 is not let's see, what did I say this was? 31.6. Yeah, that's close enough. And that's not equal to 55. So, and that's it. Hope this helped. Please visit office hours if you have any questions. Thanks.